everyone, in this lecture we will discuss about the general rate law, and we will also discuss that what will be the unit of rate constant in the case of zero order reaction, in the case of first order reaction, and in the case of second order reaction, and so on. So the general rate law is minus RA is equal to KCA to the power n. In the case of zero order reaction, the rate law is n is equal to 0 and minus RA is equal to K. So we know that rate is equal to mole per liter into time, which is equal to K. So in the case of first order reaction, in the case of zero order reaction, rate constant, the unit of rate constant is mole per liter into time, which is nothing but mole per liter is molarity divided by time. So this is the unit of rate constant for zero order reaction. So for the first order reaction, n is equal to 1. So minus RA is equal to K CA to the power 1. So the unit of rate constant in this case is mole per liter into time, and this rearrange this, we will get this is nothing but molarity, concentration is nothing but molarity, so it will be mole per liter, and this cancel with this cancel with this. So for the first order reaction, the rate constant is 1 over time or 1 over second. The rate constant, the unit of rate constant for first order reaction is 1 over second. Similarly, for second order reaction, n is equal to 2. So the rate law will be minus RA is equal to KCA to the power 2, and rate is mole per liter into time. Now this concentration, there is square on the concentration, and concentration is mole per liter, so mole square per liter square, because concentration here is square. So L cancel with L, 1 mole cancel with 1 mole, and we get liter divided by time and 2 mole. So liter divided by time and mole is the unit of rate constant in the case of second order reaction. Now for the case of general order reaction, or for the n order reaction, the n is equal to n. In this case, the unit of rate constant will be equal to mole per liter into time, and this concentration will be written as mole to the power n into liter to the power n. Now this mole and this mole are equal, so and this liter and this liter are also equal, but the time, there is no n on the time, so we can rearrange this relation 1 over time and liter, this n minus 1, here is 1, there is 1 on this liter, and we can also write this mole can be written as mole n minus 1, mole n minus 1. It can also be written as 1 over time liter n minus 1 mole n minus 1, or it can also be written as 1 over time liter by mole n minus 1 is equal to the unit of rate constant. So now put n is equal to 0, we will get this term will be 0. 1 over time liter by mole minus 1 and minus 1, and it is nothing but 1 over time 1 over liter mole inverse. So this mole, again this mole will be equal to mole per liter into time, which is nothing but molarity per second, and it is the unit of rate constant for the zero order reaction. Similarly for the first order reaction, when n is equal to 1, this term will be 0. This term will become 0, and anything to the power 0 is equal to 1. So the rate constant will be equal to 1 over time, or it will be equal to 1 over second, or 1 over minute, or something. So this is the unit of rate constant. Similarly for the second order reaction, the unit of rate constant will be equal to n will become 2. So n will become 2. Now 2 minus 1 is equal to 1. So liter divided by mole, and this is 1 over time. So it will be equal to the unit of rate constant, liter by mole divided by into time. So this will be the unit of rate constant in the case of second order reaction. So this was the general for the general order, n minus 1 into 1 over t into L divided by mole m2 to the power n minus 1 is equal to k. This is the general equation from which we can obtain the unit of rate constant for any order of reaction. Thanks.